All right, well, let's just go ahead and get started. Thank you for coming to the City of Seattle's Building Safety Month and Day of Service presentation on preparing yourself for when shift happens, earthquake readiness for the city and the household. My name is Amanda Hertzfeld, and I work with the Seattle Department of Construction and Inspections. And before we get into the presentation, I just wanted to go over a few logistical items. First, I just want to let you know this presentation is being recorded. This is so the city can post it on their website, but it is being recorded. If you have questions, you can open the chat window and you can type in your questions, and I can answer them, or my co-presenter, Dean, will answer as well. Additionally, if you need translation services or closed captioning, those features are available through the WebEx. If you go to the pull-down arrow, you can select your language, your preferred language, or closed captioning. So with that, I will jump right into the presentation. I'm going to be spending some time to talk about earthquake hazards in Seattle, as well as the city's unreinforced masonry building problem. URM stands for unreinforced masonry building, and I'll define that in just a minute. I started with the city back in November. I was hired to help lead the city towards creation of a mandatory retrofit ordinance for unreinforced masonry buildings. I will explain what that means. But prior to coming to Seattle, I spent 12 years working for FEMA, the Federal Emergency Management Agency, where I supported response and recovery efforts to a couple of different earthquakes, as well as some other natural disasters. So when we talk about earthquakes in the region, I wanted to first point out that there's multiple sources that can cause earthquakes. So a lot of people think, we have an earthquake and it all comes from the same place, but we have multiple sources of earthquakes. So we have our Cascadia subduction zone fault line that's off the Washington coast, and that line runs all the way from Vancouver Island down to Northern California. So it's a very large fault line. We also have a fault zone running right through Seattle, the Seattle fault zone. There's fault lines running through Olympia area, Tacoma, through Everett. We live in a very highly seismically active area, which is part of the reason it's so beautiful, right? So mountain building is created by earthquakes. And the reason I'm showing this is that we hear a lot of people say, well, my building survived, the Nisqually earthquake, or it survived a previous earthquake. That doesn't mean that it will survive the next earthquake, because that earthquake might be coming from a source that is closer, or it might be a larger magnitude or higher intensity earthquake. And I'll get into what that means in a moment. So when we talk about earthquakes here, think back to your elementary school plate tectonics geology classes. We are sitting on the North American plate, and we are next to two plate systems. So there's the Pacific plate, which is essentially the ocean, and then there's the Juan de Fuca plate, which is a much smaller plate that is being sandwiched underneath the North American plate. So if you were to take two rocks and push them together, you've got one that is being pushed underneath. And that being pushed underneath is what causes the subduction zone, so that really big earthquake, the big one that they talk about. And so in that tectonic setting, you can have an earthquake happening right at that point of friction where those two plates are coming together. And that's your megathrust event. That's that Cascadia subduction zone scenario. You can also have earthquakes happening much deeper. So as that plate is going underneath, this part down here, that's where you can get deep earthquakes, and those can be quite damaging as well. And then there's crustal earthquakes. And so that's like our 2001 Nisqually earthquake. So just really quickly, those megathrust earthquakes, the Cascadia scenario, the big one, we have between a 10 and 33% chance of experiencing that earthquake in the next 50 years. So relatively low probability, but we also know it can happen. So the last earthquake happened in 1700 on that fault source. And we know that those earthquakes happen between every 250 and 500 years. So it could happen this afternoon, or it could happen in 150 years from now. The point being, we have a lot of geologic evidence that says it will happen again. And so it's really important that we take appropriate measures to be ready for when that does happen. The Nisqually earthquake was a deep earthquake. And so it's happening on the part that's more subducting, that is lower. And we have an 86% chance of that happening in the next 50 years. So that's a really high probability. So we want to make sure that our buildings in the city are ready for shaking associated with that type of event, because it's very likely that that will happen again in the near future. And then lastly, there's the crustal type earthquake. So that's what we would see in a Seattle fault style earthquake. And there's only a 5 to 7% chance of that happening in the next 50 years. So that's a much lower probability. I did want to spend just a moment and talk about the difference between magnitude versus intensity. So a lot of times you'll hear people talk about, the Cascadia event is a magnitude 9.1 or 9.2. The Japan Tohoku event that created the big tsunami was also a magnitude 9 earthquake. Our Seattle fault, our Nisqually earthquake. I'm talking about lots of different earthquakes here. The Nisqually earthquake was I want to say it was a magnitude 6.8. And the difference between magnitude and what you see here, it says Mercalli, that's intensity scale, is a difference in the actual, so magnitude is the amount of energy being released, and that changes. There's only one number for that. So Nisqually was a 6.8 magnitude earthquake, but that intensity is felt differently, dependent on your proximity to where that epicenter or that earthquake started from. So, for example, a magnitude 9 Cascadia earthquake is a very high intensity earthquake, but it is rather very high magnitude earthquake. But the farther you are away from that fault zone, the less intensity that earthquake is gonna have. And Dean, I see you have a question.
Yeah, I was just wondering, recently there was the earthquake in Turkey. Did that have a specific magnitude given to it?
Yes, it did. I don't. That's a really good question that I should have, because we were just talking about that yesterday.
It certainly is on a lot of people's minds.
Yeah, here, let me just Google that. Really? Turkey earthquake was Turkey earthquake. That was a magnitude 7.8.
Okay, and there was a lot of destruction with that.
There was a lot of destruction, and part of that was so that fault line ran right under multiple cities, and it wasn't like a very deep earthquake. That was much, so you're going to have higher intensity along with that higher shaking.
Got it. Thank you.
Hmm. So in the Seattle area, it's really a question of if, not when, the next earthquake will happen. So this little map that you see on the left, these are all the earthquakes, the major earthquakes that have happened since 1880 in Washington state. And so you can see there's earthquake hazard over in southeastern Washington. There are fault lines over there. It's not just a Western Washington problem. But you can see there's a lot of earthquakes that have happened in the greater Puget Sound. And again, just reiterating, we have an 86% chance of experiencing a magnitude 6.8 earthquake similar to Nisqually in the next 50 years. Down on the bottom here, these are just pictures from very large earthquakes that have happened in the last 20-ish years. So Sichuan, China had a very large earthquake. Chile, 2010, had a very large earthquake. And if you start to look at these images, you see there's a lot, the pictures all kind of look the same in that there's a lot of bricks that are on the ground. And we're going to spend most of the rest of the presentation talking about why brick buildings, specifically unreinforced masonry buildings, perform poorly in earthquakes and what we can do about that so we can reduce damages and injuries and even fatalities in a future earthquake event. But first, I did want to reiterate, so we have a very high earthquake risk in the Pacific Northwest. We cannot predict when an earthquake will happen, but we can warn in advance. So like I said, the intensity of an earthquake changes based off of your proximity to that earthquake epicenter. There's a new warning system in place that can give you around 10 seconds of warning. So how that system works is there are monitors all over the state. And when they sense an earthquake, so earthquakes happen in two types of waves. So the first wave is called the primary wave or the P wave. And that wave happens, it travels faster than the secondary waves, which are stronger in shaking. So because radio essentially can travel faster than earthquake waves, these sensors can sense the earthquake and send a warning to your phone and tell you there's an earthquake coming. Be prepared, drop cover, and hold on. And so if you are interested in downloading this app, and again, it gives you around 10 seconds of warning, depending on where the earthquake source is coming from. If it's a Cascadia earthquake, you'll get around the 10 seconds. Maybe even a little bit longer. But the app is called MyShake. And when you look at it, it says it's through Berkeley, but they're just the ones running the app. So you can download the app MyShake on your phone and get early warning on your phone. And I just want to remind you that in an earthquake, you do drop cover and hold on. Most injuries in earthquakes actually happen from people moving about during an earthquake. So like trying to evacuate a building, for example, is a really bad idea. Number one, because you are walking as things are moving all around you. So there's a high potential for tripping or for things falling or hitting you. And then as you'll see in just a moment, when you go outside in an earthquake, anything that's on the face of a building or that is on the roof of a building has a very high potential to come down. So if you are outside in the street during an earthquake, that's not actually a very safe place to be. So when it comes to earthquake readiness, there's a few things I want to cover. So this graphic is used in the field of emergency management, which is getting a little bit more press these days. Like I mentioned that I used to work for FEMA, which is the Federal Emergency Management Agency. So emergency management is not just responding to a disaster. It is about how do you understand what the hazards are, understanding what you can do to be prepared for them. So how can you be ready for an emergency itself? And so that's like having a preparedness kit, having that food and water, having a first aid kit. But there's an additional step in that kind of preparedness realm before an event happens on how do we actually minimize the effects of a disaster happening. So in the Pacific Northwest, we know earthquakes can happen. And we know what to do during an earthquake, right? So we know to drop cover and hold on. We also know that we can't prevent earthquakes from happening, but we can reduce those damages. So we know what types of things get damaged in earthquake, and we actually know how to prevent those damages from happening. So I'm going to talk a little bit about that. So in 1933, going back in time here, there was a magnitude 6.4 earthquake in California. 6.4 isn't a super large earthquake. Our Nisqually event was a 6.8. You know, 6.4 isn't huge. It's not nothing. But this earthquake, as you can see, caused a lot of damage. There were between 115 and 120 fatalities. Over 70 schools were destroyed and seriously damaged 120 buildings, causing over $40 million in property damage in 1933. So this event today would be much more damaging in today's dollars. But as you can see, there's the group of women standing on top of a pile of bricks. This earthquake is really when we learned that unreinforced brick buildings, so brick buildings without any reinforcing steel in them, perform really poorly in earthquakes. So here's a picture from our 2001 Nisqually earthquake. You can see this building here. I don't think you can see my cursor. So you can see that the brick on the building really crumbled down into the street. So if you were inside this building and decided there's an earthquake, I'm going to run outside, you would have been absolutely pummeled by the bricks falling off of this building. So the best course of action is really to stay inside the building, to drop cover and hold on. So you can see, there's the people standing on their car. Their car had been covered in bricks and obviously not much of that car is left. So we know that these buildings, unreinforced masonry buildings, perform very poorly in earthquakes. There were no fatalities associated with these buildings in this event, which is very good. But there could have been. Had you been standing on the street right here, you could have died. You definitely could have been significantly injured. Looking at other earthquakes that have happened since the 1933 earthquake in California, we obviously just talked about Nisqually, but I wanted to call attention to the Christchurch, New Zealand earthquake that happened in 2001. So that very top picture there, you can see beautiful city, and then right underneath that, you see that haze all around the city. That is dust from the collapsed unreinforced masonry buildings in the city. And then that very bottom picture that you see, that is most of those buildings removed. So after the earthquake in New Zealand, they had many fatalities from unreinforced masonry buildings. They had to shut down almost their entire downtown area for multiple years to demolish these buildings and to figure out rebuilding strategies. And they also created 2 new landfills. They call it Rubble Mountain, from having to demolish so many buildings and remove debris, in addition to the economic impacts and just the trauma of losing lives and injuries from this earthquake. So unreinforced masonry buildings are a significant vulnerability in our city to earthquakes. However, we know how to fix this. We know how to fix this problem through engineering. So this little graphic that you see on the side is showing an unreinforced masonry wall, and the dotted lines are representing the reinforcements that we can add. So you can brace the walls to prevent the walls from moving out of plane. You can also bolt the walls to the floor, or sorry, the floors to the wall to prevent them from falling. And then you can also add additional structural frame support. So in this image, you can see this is how URM buildings fail. So in the first little graphic, you can see the parapet up at the top. So the piece that's it's unreinforced, it's kind of free floating, if you will. In an earthquake, that can fall off. And if you're this pedestrian, this can come down and hit you, and it's very dangerous. The second image here, you can see because the wall is unreinforced, the wall itself can fracture, and then the shaking can actually cause the floors and ceilings to separate from the wall and collapse. So these buildings really are collapse hazards. And in the third graphic, here you can see that by bracing the parapet and by connecting the roof to the walls and the floors to the walls, you can prevent that collapse hazard in that building. So doing this, the building is still vulnerable to shaking, and you'll still likely have damage to the building, but the collapse of the building and the potential loss of life is significantly reduced. So before I talk any further, I wanted to just point out we have a ton of brick buildings in Seattle. And that is largely because after the Seattle fire in 1989, the mayor called together all the businessmen from the city and passed an ordinance that buildings needed to be made of fireproof materials. And you know what's really fireproof? Brick. So we kind of rebuilt our city after the Great Seattle Fire with brick buildings. So really great for one hazard, but not the most resilient thinking when it comes to other hazards. And obviously this was before, oh, and you know what, this should say 1889 and not 1989.
I think that is the date of the fire is 1889.
Yeah.
I was just looking at that going, yeah, no, I think it was a little earlier.
I think I need to change that slide.
No, but
But the
good catch.
yeah, so this fire happened before that 1933 earthquake in California, where we really learned how bad bricks are in earthquakes. So there hadn't really been a lot of earthquakes during the time of the white settler in Seattle. So we weren't as aware of our earthquake hazard. And then additionally, I'll just point out that the science of earthquakes is still relatively young. While we know that earthquakes can happen, the actual theory of plate tectonics and like the understanding of one plate subducting under another wasn't widely accepted in the scientific community until the 1960s. So we didn't really know about our Cascadia subduction zone until the mid 80s, the mid 1980s. So when it comes to addressing URMs, we are still catching up to the science of understanding our geologic risk in the area. So Seattle has around 1,100 unreinforced masonry buildings. So there's a map on the right showing the red dots that represent unreinforced masonry buildings. Around 75 of these are what we have defined as critical vulnerability, meaning they're emergency service facilities or schools, or they are an essential facility. We have around 184 that are high vulnerability. So that's buildings that are over 3 stories in height and are on poor soil. So that means that they're either in landslide prone areas or liquefaction areas, which is where in an earthquake, the soil can essentially liquefy, allowing buildings to either topple over or it just becomes really, really soft, which intensifies shaking. And then we've classified all the rest into medium vulnerability buildings. You'll see there's no low on this scale. There is no low vulnerability URMs. All URMs are either critical, high, or in this other category of medium. So if you are interested in learning what these buildings are, you can actually go to the SDCI website. If you Google SDCI URM buildings, you will be taken to this page, and under project documents, you can scroll down to the URM list, and you can both use pull that up in a viewer, a spatial viewer, like a map, or you can see a PDF document of all of the buildings and read a little bit more about what these buildings are and what the methodology was in identifying them. So since the Nisqually earthquake, Seattle has been actively trying to understand our vulnerability and forge a pathway forward in trying to repair or seismically retrofit these buildings. It is a really complicated issue. So after Nisqually, we had multiple engineers go out and try and understand where these buildings are. And the city also had a hired engineer that helped develop our inventory of URM buildings. And we developed a policy committee of folks to kind of go through and understand what are the implications of asking people to retrofit these buildings. Like, this is an expensive ask for building owners. how do we, and what is the minimum level of retrofit that we should require? And so the city's spent numerous years understanding the seismic hazard, developing the inventory of these buildings, developing a proposed standard for future retrofits. And in 2021, the city passed a resolution, and that resolution, I will go to this page, Resolution 32033, signed by the City Council and the Mayor under the Durkin administration, asked the city to develop a URM retrofit program that defines what a URM is, identifies the type of retrofit required, establishes a timeline for retrofitting and how this will be enforced. And it also asks us to develop a variety of funding opportunities and financial incentives for building owners to alleviate or reduce the expense associated with the retrofit. So we are currently working on this, but there's a few things I wanted to highlight. So one is that the primary goal of this ordinance is to protect life safety by preventing the building from collapsing. That is different from having a building that is fully functional after an earthquake. And I'll talk about that in a little bit, but I want to point out that a retrofitted building will still be, should still anticipate damage in an earthquake. That damage just won't be such that it will collapse on you. It's purely to reduce deaths in an earthquake. There are opportunities for building owners to retrofit to higher standards so that their building experiences less damage and is more functional. But it is more expensive and more complicated to do that. And so kind of from an equity standpoint, the city is looking to reduce the burden on building owners and work on specific life safety requirements. There are additional goals of this ordinance. One is we do want to preserve our culturally significant landmarks and historic structures. URM buildings are old buildings. They generally were stopped. We don't see many of them after being built after 1945. But these are, so they're old buildings, and we don't want to just knock down everything old in the city. We want to improve the city's resiliency to earthquake events. So by retrofitting these buildings, we will speed up recovery after an earthquake in the city, as well as minimize deaths and damages. And then we want to minimize the impact of this mandatory retrofit program on vulnerable populations. So a lot of these buildings are, because they're so old and have not necessarily been modernized, they tend to be naturally occurring affordable housing. And so obviously the city has some real problems right now with affordable housing and just availability of housing. And we don't want our efforts to improve the city's seismic safety to unintentionally result in a reduction in housing, especially affordable housing. So it is really a complex balance of a complex balance of both affordable housing, historic preservation, and life safety as we move forward to figure this out. So looking at our timeline, we are finishing right now what I'm calling our baseline retrofit standard, or our minimum level of seismic compliance. And we'll be having some webinars in June to share what that means. And so that's really looking at the engineering specifics of how do you retrofit a building, a URM building, to reduce its collapse potential in an earthquake. In 2024, so next year, we are hoping to identify and have more communication with building owners and tenants about funding sources available, whether that is through low interest loans, potential grants, or even looking at some transfer of development rights programs, which is where a building owner of a URM could potentially sell their development rights, meaning, if they have a 3-story building right now, but they're parcel is zoned to be up to 6, for example, they could sell the development rights for those 3 extra floors and use that funding to retrofit their building. The soonest that we could adopt an ordinance right now would be summer of 2025. And previous policy recommendations to the city have suggested between 6 and 13 years for compliance. So that means that a critical building would have around 6 years to retrofit, but those medium buildings would have 13. Dean, I see you have a question. Are you there, Dean?
Let me unmute.
Okay.
So I had a question that I just dropped into the chat. You mentioned that there are going to be seminars in regards to this in June. Is there are those for specific people, or who would you recommend go to those seminars in June?
Yeah, so those will be open to anyone
Uh-huh.
because they'll be a little bit technical. It's explaining the technical standard of the retrofit fix. It is probably more digestible for someone familiar with engineering, architecture, a more technical background.
Okay.
But we anticipate there will be many building owners that will be interested in understanding the scope of what will be asked of them come
Yeah,
that future ordinance.
that is a huge scope. So thank you. Great.
Yeah, good question. So, you know, when I introduced this presentation, I said this was for the city's Building Safety Month. And I know that building codes themselves, people tend to not be very excited about. But I think it's really an important thing that the public understand a little bit better. So building codes are the regulations on the construction standards for the design of our buildings, both the structure, as well as the mechanical and plumbing and electrical of a building. And there are many studies that show that adopting modern building codes, so building codes change over time. So as we're seeing with the Turkey earthquake, for example, there's been many articles coming out that, Turkey has really good building codes. Why did we see all of this damage? Well, and that's partially because Turkey wasn't actually enforcing many of their building codes. And so having a rule in place saying a building must be built like this in order to be safe, but then not doing it, not building safely, that doesn't help anyone, right? And I just wanted to point out that so Seattle is very progressive in their building codes. And in addition to adopting modern building codes, Seattle has actually revised their building codes to account for stronger earthquakes. So after learning about some of the science involved with the Cascadia subduction zone, and how I mentioned that liquefaction, for example, can increase the intensity of an earthquake, we have learned that because of Seattle's tectonic setting on top of glacial fill and man-made fill, that we know that intensity of shaking can the intensity of the shaking can be increased in the Seattle area in a Cascadia fault scenario, specifically for really tall buildings. And so both Seattle and Bellevue actually have revised their building code to require more stringent design guidelines on skyscrapers, so buildings over 240 feet. So Seattle is doing a really great job, both with adopting modern building codes and adapting to those. And this looking at unreinforced masonry buildings is really it's very challenging to bring an older building up to modern code, but you can retrofit to bring it up to at least a higher percentage of modern code. So this is just a little bit of a shout out to all the building code inspectors and the people doing enforcement. It is a thankless job until there's an earthquake and you see the buildings that stayed standing and the buildings that protected the safety of their occupants and the people walking by. So just a couple things as I wrap up here. So building codes are different than building performance. And that means, so our building codes are generally designed to a life safety standard. That's a phrase I've used a few times here. And what that means is that the occupants are able to exit the building after an earthquake, but that the building is expected to have considerable damage. URMs right now are not on this scale. So URM buildings are prone to collapse. And so looking at our retrofit program, we are looking at both collapse, we're looking primarily at collapse prevention. That being said, a URM building owner could do advanced engineering to bring that building up into higher standards to include life safety or even immediate occupancy. There is a lot of talk in the building safety community, if you will, about requiring future buildings to be more focused on operational capacity. So meaning that after an earthquake, the building would be just fine and operational and you could use it. That does add time and cost to the design. But the point being that I'm trying to make here is that building codes are a life safety standard. So buildings today are designed to not kill you in an earthquake, but there is expected downtime for repair and reoccupancy after an event. And that's where having your preparedness kits comes into place. And if you're a building or a business in one of these buildings, it's important to have a plan in place to know how will your business continue operations if the building itself has some damage after an earthquake. So if you're interested in learning more, I've got a number of links here that I will briefly walk through. But I first wanted to point out, so there's a really amazing book. I have a copy that I take everywhere with me. It's called The Big One by Dr. Lucy Jones. She's a seismologist based out of California. She is often referred to as the Beyonce of earthquakes, and you can't compete with that, right? But she has an amazing Twitter presence, and she is full of information about earthquakes, as well as she's a really strong advocate for having building codes that are more focused on functional recovery of a building rather than life safety. So it's a really good read too. It's not super technical. It's an enjoyable one. So if you are interested in learning more, the first link I have here is the Pacific Northwest Seismic Network, or PNSN. They're located in the University of Washington, and they are responsible for monitoring all of the earthquakes in the Pacific Northwest. There are some really smart individuals that work there, and they can answer your science questions. They can answer any of your questions about earthquake early warning as well. The next link is the Earthquake Engineering Research Institute, or EERI. They are an international group that does a great job of bringing together geologists and engineers after a damaging earthquake has happened so that we can learn the most from that event to inform future building codes and to understand what happened and why. And they have, if you go to learningfromearthquakes.org, they have a whole site dedicated to the Turkey earthquake, for example, with amazing pictures as well as like studies on what failed and why, or what didn't fail and why. Next is the USGS, the U.S. Geologic Survey. So that's the federal government's geologic group, and they're the ones that develop our seismic maps. And so there's, yeah, you can learn all about different types of earthquakes across the entire country. Next is FEMA, Federal Emergency Management Agency. In addition to responding to events, they do a lot of pre-disaster mitigation. So they can help a lot with understanding how to retrofit buildings and bring people together in support of retrofitting buildings. And they also have great guidelines on what should be in your preparedness kit. The last two links are the Seattle Office of Emergency Management and the Washington State Emergency Management Division. Those are the state and local arms of emergency management. So just like FEMA does response and preparedness and pre-disaster planning, so too does Seattle Office of Emergency Management and Washington EMD Emergency Management Division. So their sites both have links to specific hazard information in the area as well as preparedness tips. And with that, this is my email address for anyone that's interested. You're welcome to email me with questions. I can talk about earthquakes all day, every day. And so I will pause for just a minute before passing it over to Dean. Should there be any other questions? Okay, well, with that, why don't I stop sharing and I will pass the baton over to you, Dean.
Sure. Does anybody need a break before we continue on? Nice to see some faces in here. Derek, thank you very much for logging in. Christy, anyone? Okay. I'm going to go ahead and share my screen and I'll go ahead and continue on. I do want to remind people that this is being recorded so we can review this later. And I'll go ahead and get started here. Starting with sharing me. Yes. And now I'm going to share. Go to screen 2. And Amanda, could you confirm that I'm showing the right earthquake home retrofit prescriptive plan set?
I'm not actually seeing. Oh, there we go.
Okay,
Now we're good. Yeah,
great.
yeah.
And then the other thing is, are you monitoring the chat?
Yes.
Okay, everybody ready to go? Fantastic. Okay, my name is Dean Greenleaf. I'm a permit process leader here at the Seattle Department of Construction and Inspections. My set for Building Safety Month and for the earthquake home retrofits is focused on the earthquake home retrofit, specifically a prescriptive plan set that we have. This is a prescriptive approach and plan set. If you're having any difficulty hearing me or understanding what I'm saying, Amanda, thank you. She's going to be monitoring the chat. You're also welcome to raise your hand, which should be one of the options in the WebEx there. If you would like, this is closed captions. There are also translation services. Go to the lower left under where it says CC, and you can choose a language. But I've already said that this is being recorded. In general, you'll be muted. You're welcome to unmute yourselves if you have a question, but in general, we're going to probably keep video off and we'll try to keep things either in the chat or at specific times so that we don't have a lot of noise. As I said, I work at the Seattle Department of Construction Inspection. I've been here about 15 years. I've worked to become a subject matter expert on this program and specifically earthquake home retrofits. I'm familiar with residential construction and have worked both as residential and commercial occupancy and construction, but I'm most familiar with what we have a lot of here in Seattle, which is wood light framed homes. Service is one of the specific values that we look at here. I'm pretty proud of the service that I give to the city and working as a permit specialist and as a permit process leader. Also, this specific program is one of several. This program is designed to be more applicable to people without an engineering degree or who do not want to hire an engineer or architect to do work on their own homes. So equity, respect, service, quality, and integrity are something we start every presentation with. So the goal here is to kind of help you understand more about the prescriptive earthquake home retrofit, or the PEHR. It should say earthquake home retrofit, but it autocorrects to her all the time. So just to give a basic idea for this, feel free to raise your hand if you have a question. Let's give an example of that. Raise your hands if you were in Seattle when the Nisqually earthquake hit. That would be at 10:54 on February 28th, 2001. Anyone? Amanda was? Okay, good. Anybody else there? All right. So depending on where you're at, this might be something that's very personal to you, but also that's an example of kind of how to raise your hand or to lower your hand down if you do have questions. Thank you. Move that over there. So first off, the earthquakes, and what Amanda talked about very well was to be prepared, and to try to anticipate building safety. We're also going to talk a little bit about the um, history of earthquake home retrofits, what and where these retrofits happen to existing homes to strengthen the existing homes. I often will come back to the ABCs, or anchor, brace, and connect to an existing building. The plan set has certain key pages that I'm going to talk about, and we'll go over those briefly. There's more information available, and there are classes periodically that are specifically for this plan set. My goal here today is to give you an overview of those key pages and the beginning of an understanding on how to apply and some of the resources for this specific home retrofit throughout the Seattle area. All right. So again, I mentioned that this is a prescriptive program. It is a program that has been set up through past engineering using schedules and charts, and has an idea on basic accepted practice. This is a kind of pre-engineered approach, and you will need to pick from an existing chart and an existing wall lengths and size and shape. This does not apply to all the homes. The idea is to improve resistance to as many single family homes as we can while still falling within the prescriptive requirements of this plan set. I want to make it really clear this will not earthquake proof your home, but it will help lower damage and increase recovery and make the area and neighborhoods more resilient in the case of an earthquake. Yeah. So the current EHR plan set is based off of the FEMA P1100 drawings. They're part of a federal emergency management agency, and the full name is for that plan set and that set of documents is the vulnerability-based seismic assessment and retrofit of 1 and 2 family dwellings, which we really had a hard time calling it the VISAPAR 2 and 1, or 1 and 2. So we came up with the EHR, or earthquake home retrofits, and the P1100 is a fairly complex and meant to apply all over the country by the Federal Emergency Management Agency. Washington Association of Building Officials, or WABO, brought that in and has simplified the plan set itself and made it as widely applicable as we can while staying within the parameters of that prescriptive plan set to be used here in Washington State. Several jurisdictions do use this plan set. It's the project impact was applicable mostly in Seattle. This new plan set is actually applicable in many jurisdictions and is already being used in Tacoma, Seattle, Mercer Island, Bellevue, Shoreline, trying to remember a couple others, but in several different areas. Many of these jurisdictions use a mypermit.com, and it's all online. So the idea is to improve performance, um, and the largest area where earthquake damage or earthquake forces can cause damage to a building is at the lower portion of the building, specifically where the ground and foundation meet the building structure and below the first floor framing. So the idea here is the prescriptive plan set is designed around a two-story wood framed home with that first floor being wood framed, and then there's a wall below it or a foundation below it. There are other options if it's a brick home or if it's a apartment building or if it is does not meet that or is a three-story building. So here are some examples of where those forces have done damage. On the right is a photo that I've used multiple times. This is a building from the California earthquake in 1994. The building itself is fallen off of its foundation, and the porch there is almost entirely destroyed. On the left side is from the Wabo earthquake, their own earthquake webpage, and this shows a fairly simple dwelling, but it is off of those off of the foundation, and has fallen to the side there. So when you're looking to retrofit your home to better resist earthquake forces, these issues are great places to start. Look at the foundation. Look at your connections between the home's first floor and the exterior wall and that foundation, and specifically look to brace that short wall between the foundation and the first floor that's commonly called a pony wall or a cripple wall. We will be using the phrase cripple wall in this presentation today. So picture here is from the San Fernando earthquake. The building has a small stucco exterior, but it's wood framed. That wood framing has come off the foundation. You can see the sill plate is now entirely sitting on the foundation by itself with no structure above it. All right, so when is any earthquake home retrofit needed? So if the building was built after about the early 1980s, probably will not need a seismic retrofit, probably already will have engineered anchors and bracing, and if it has a cripple wall, it'll be braced. If your home could be considered a craftsman or a mid-century modern or an older home, then you may need a retrofit, especially if the home is as old as the one on the left-hand picture there. That home was built in 1865. If there are questions, or if you're kind of in the in-between area there or have had additions to your house, probably a good idea to consult with a contractor or architect. So real quick question. For the house on the left, does anybody know where that is? Any hands raised? Any guesses? Not so much. Okay. So on the left, the Hiram Burnett photo, that was taken in the early 1900s. The hint there is the First Methodist Church that is behind it. That is still standing. This is a house that was on the corner of 4th and Columbia in downtown Seattle. I doubt the porch or those steps are compliant, but on the left there, you'll see the start of the Rainier Club, and that building is also still in existence. So prior to 1980, homes were typically constructed without adequate anchorage, bracing, or connections. There are several items that are not covered in this plan set that I would recommend you look at. They can have impact in a seismic event, but the prescriptive plan set is specifically for the foundation and strengthening the house. This is what is not covered in the plan set are chimneys, work above the first floor, and any type of interior walls or columns. Pretty houses. So there's on the left there is a drawing. The interior walls are columns. The columns I'm showing there, those are the posts, either on piers or resting right on the ground. This is a good example of an interior crawl space. The prescriptive plan set look on specific areas around the home's perimeter, and they are looking for specific characteristics. We're looking for a basement or crawl space. The EHR plan set is not something that works really well with a slab on grade or with a building that doesn't have a concrete foundation. The EHR plan set is limited to 1 or 2-story buildings above a basement, and that is measured above the first framed floor. The square footage of the building is limited, but it is limited to either 2,000 square feet for a single family home or 3,000 square feet for a single family home with 2 stories. So it's fairly broad, especially for older houses, but a modern house or a very large house would exceed what would be covered under this prescriptive plan set. Wall and roof finishes that can be brought up. Some things will make the building heavier and it will react differently in an earthquake. Brick veneer on the outside, tile roofs on the roof. Stucco can work, but if it's a brick building or if there are tile roofs, then that could create an issue. So back to those ABCs: anchor, brace, and connect. So the detail on the left is showing what we call anchor bolts. That is probably one of the most common ways, especially current buildings are anchored to the foundation. Those bolts are often set when the foundation is poured. In a retrofit, they are typically drilled in, or there are side plates that are used. But those are mechanically anchored or anchored through use of chemical epoxies and stuff like that. When we talk about bracing, a lot of times they'll put up oriented strand board or plywood. The bracing is shown here as the lighter tan where the word ventilation holes is, and that is to stiffen that lower wall. And then to connect to the framing, that is to connect to that first floor framing. This is what is called often called a hurricane clip or a joist clip, and this goes between the vertical wall framing and that first floor framing to help get a better connection and transfer forces through it. All right. So the main part of the project impact is showing how that anchor bracing and connection is done to a single family home. So it is a complete package. You can't submit one detail or 2 details. You also need to retrofit the whole existing basement or the whole crawl space. But each of these have different impacts and different parts of it are important. The key pages that I'm going to talk about today, just to make you a little bit familiar with it, is the cover sheet or sheet S0, the earthquake retrofit schedule, which is sheet S3.1, and there's one of those for 1-story dwellings and one of those for 2-story dwellings. And then sheet S4, or the retrofit foundation and retrofit layout. The sheet S0, or the cover sheet, is probably the most important when you're screening or when you're trying to figure out if you can use this plan set or not. There are 11 qualifying questions. You can either be compliant or non-compliant for each one of these 11 questions. If any of these are shown as being non-compliant, probably cannot use this prescriptive plan set. I'm going to go through each one of these, but probably one of the most important one is that it's a dwelling is wood, light frame dwelling that is 2 stories or less in height, item number 2. The dwelling has a crawl space or basement, and the perimeter is supported on cripple walls, foundation stem walls, or a retrofitted system that is brought up to foundation stem walls. Without a foundation to connect to, this plan set really doesn't work. This also can be an issue in steep slopes, where the slope is close to steep slope at 30% from one end to another, or if it has, like I said, heavy roof or heavy wall materials. All right. So I'm going to run through an example here real quick with each one of these 11 questions. So this is Fort Lawton. This is what was formerly called the Admiral's House. We're looking at, well, let's take a look. Is it 1 or 2 family, 1 or 2 stories? Yes. This is a 2-story building with a full basement. It has an attic, but it does not have a livable attic space. It does not have a permanent stairway. Great. 2 stories over a basement. The first framed floor is about even with the top of those steps there on the left. Does it have a crawl space or basement and a foundation? This does have a complete concrete foundation, and it does have a complete basement. So we're good there. Cripple walls under 7 feet tall. Well, it doesn't look like it has much of a cripple wall at all. They are definitely below 7 feet tall. Looks like it's about maybe 3 steps high max, which would be about 22 inches. So we're good there. Under a 30% slope, that would be measured from the lower right-hand corner of the building on the right hand of the picture to the upper left-hand corner of the picture. Now, assuming this is fairly flat, we're looking at well under 30% slope. Sure. So does it have a lightweight roof? Yeah, it looks like it's got an asphalt shingle roof. Probably was put on well after the house was built. This is an exterior that could be stucco, but it is definitely not brick, and therefore light roof, no brick, looking good. Last one. So we have a maximum square footage of 4,000 square feet because this is a 2-story house. 2,000 square feet. It looks, yeah. Wait, nope. The actual square footage is close to 7,300 square feet. This is a huge house. Now, the Admiral's house also was used as a ballroom and a social area. And while you would not necessarily include the basement, the entire area of the space would make this, would exceed what could be used as a prescriptive plan set. Okay, if there aren't any questions in the chat, I'm going to continue on. Okay. So the floor plan, the earthquake home retrofit plan set, or the EHR plan set. So this is the second page of 3 that are really important. So once the assessment's complete, it's time to show what's there and what's going to be done to retrofit the building. The plan set is really the best place where this can be shown. The schedule is good and it will show important information, but a floor plan of that basement or crawl space is really critical to showing not only what's there, but what is going to be done to retrofit that existing there. You want to measure and mark the existing conditions. This floor plan should be to scale, and you need to show the bracing for each wall length. Now, the bracing here is shown with a line just inside the foundation. The length of the new structural wall panel, which is in the lower left corner there, that's showing a 16-foot braced wall panel, which is a great length. By braced wall panel, I mean the bracing of that cripple wall between the foundation and the first floor. Okay, so the cripple wall or the braced wall panel, the oriented strand board there is showing the braced wall panel. This one is really short and would be very difficult to drill down into. So what's been used here is a universal retrofit side anchor plate, the URFP, Universal Retrofit Flexible Plate. Retrofit, I think, is RF, but that is one way to connect to that cripple wall to the foundation. So the maximum height of these walls is now 7 feet, which is a lot bigger than it used to be. And the minimum width is 2 feet, which is less, more narrow than it used to be, than what used to be allowed. But a 2-foot wide cripple wall would also have to have additional anchors. So the last page in this earthquake home retrofit plan set, the one that shows how much and how many braced wall panels you need, what's the total length, the number of anchors, and the number of connections to that sill or the framing is shown in what they call the earthquake home retrofit schedule. So this was originally set up for 2 braced wall lengths, and it had a multiple pages based on a different design response for 1 and 2 story heavy and light construction. The WABO plan set that we're using, the one that is on our website, has 2, 1 for a single story and 1 for a 2-story condition. So most important thing is to start off with knowing that you're on the single story or the 2-story condition, and then looking at the total area or the square foot. Now this would be the total area from that first framed floor, does not have to include the basement, but the first framed floor, and then if you have a second floor above that. This would not include decks. This would not include a slab on grade garage. This would be for the retrofitted part of the home. The other one is the cripple wall height. You'll notice that there is a scale, or there is a variety. We have a variety here of 2 to 4 feet, 4 to 6 feet, and 6 to 7 feet. If there is no cripple wall height, you can enter 0. Anything between 0 and 1 or 1 and 2, you'll notice that they cannot put in tie downs. You would have to use side anchors, and you can't use tie downs on either end. So, for example, we have, let's say, a 400 square foot, I'm sorry, a 4-foot wall and 1,400 square feet of area. So on the left is 1-story condition, single-story house, 1,400 square feet. That would be between 1,201 and 1,500. The 4-foot wall would be between 2'1" and 4'0". So going from the row and the column, we're looking at a cripple wall. The amount of of each of the 2 braced wall panel sections would be either 10.7 or 8 feet. So This would show the length of one of those panels. The total number of panels, or the total length of braced wall panels along each exterior wall, north, south, east, or west, would either be 16 or 21 foot, 21.4 feet, or 21 feet, 4 inches. I had to figure that out. Walking through it, you'll also see that there are numbers 1, 2, 3, 4, 5, 6, and 7 that have a circle in them. The circled numbers each have notes that describe each item. If you go through this chart using those items, starting with the weight category at number 1, the total area number 2, it's a great way to go through this and determine how much you need. So I'm very familiar with this next slide. I've been working with the application process for a while, both as a PS2 and as a permit process leader. These are research, assessment, floor plan, now the actual application. So all construction projects, including the prescriptive plan set, they all start the same way, through a preliminary application. The good thing about this plan set is you can submit it for screening the same way you would submit it for a simple STFI, or subject to field inspection permit. You do not need an intake appointment. That can save you a lot of time looking for a construction project. This will be screened and then brought in without an intake appointment, but it does require a plan review. This plan review is expedited, and the fees for this are based on about 1 hour of time versus the actual valuation of the project. So there will be plan review, there may be corrections, but the idea is to submit it for screening, have the project brought in and reviewed, and then their inspections. So just to recap here, this program looks to strengthen or retrofit the existing structure. The existing single-family dwelling or two-family dwellings is what it's focused on. The idea is to anchor to the foundation, brace that cripple wall or the wood framing below the first floor, and connect to that first floor wood frame. Single family homes, light frame construction, 2 stories or less. If there are brick veneer or tile roofs, that could be an issue. And this earthquake home retrofit plan set specifically has been designed to be one of several methods to retrofit your home. This one does not have to have an architect. You do not have to schedule an intake appointment. It can be cheaper than other permits, but more importantly, this gives you an opportunity to use a plan set that is pre-existing and use a prescriptive method without expensive engineering. Here's some resources, both the WABO resources and our website. We have a specific page that is entirely devoted to earthquake home retrofits, and this gives both the using a subject to field inspection, using an engineered solution, and using the prescriptive plan set, which you have just learned a little bit about. If you have questions about us, you can ask us a question online. Our chat service is Monday through Friday. Look for the blue circle with the chat box in it, or go to the ASC virtual counter, and you can either chat with somebody live or you can submit a question. This is a new service that we're really pretty proud of, and it can save you a trip downtown. And I just love that last picture. There's my email address. I work as a subject matter expert with Kristen Malik, who is also working with this prescriptive plan set. And we're in the process of training up our structural plans examiners, our building plans examiners, and our permit specialists to be able to answer your questions and screen these drawings for intake. Thank you very much for your time, and thank you very much for logging in and taking a look at this. Look forward to helping you in making Seattle a more strong and resilient city. And if there are any questions, I'd like to check with Amanda now. Amanda, are there any questions that we were in the chat at all?
No, there are no questions.
There are no questions. All right. Well, I just wanted to say thank you very much. I'd also like to thank Derek for logging in, and Christy, and oh my gosh, Wendy, Amanda, and Heather. Thank you so much for your help with this. If there are no further questions, we will be available until the end of the time, but I think we'll probably stop recording here shortly. If that's okay with you, Heather.
And we did just get a question. So
Yeah.
Christy's asking if I'm looking to buy a new house,
Oh,
should I be looking at properties built after 1980?
um, it kind of depends upon the house. What I would recommend before you buy a house, well, most houses now will have a building inspector's report or a third party inspection report, and they will tell you what type of retrofit would be recommended. About 2 years ago, I bought a house that is early 1900s, which had undergone a complete retrofit before I got into the house. I was glad to see that it was there. But if you're looking to buy a new house, I don't think that this necessarily needs to be a deal breaker, but you'd probably want to have an inspector look at the whole house. The retrofit is something I would certainly recommend, especially with houses and older houses and more expensive houses.
Yeah,
Sorry.
that retrofit cost to do the
Yeah.
bracing and bolting to the foundation, that generally costs between $3,000 and $7,000. So, if you're
Yeah,
trying
I've
to,
seen some people go up to 15 depending. It also depends if it's a finished basement or not.
Mhm.
But a typical crawl space retrofit is very doable, um, but and could be um, somewhere between probably 7 and 10 at this point. Good question, Amanda. As far as just getting an idea, it would probably be something you would look into if you were buying an older house that did not have a strong connection to the foundation.
Thanks. Sorry, you were saying that I should, because I've looked at some inspection report, but don't recall ever seeing any keywords such as retrofit.
Hmm.
So I should be asking specifically about this.
What I would recommend is ask the person, is the found what does the state of the foundation, and how is the foundation connected to the house? They will probably be looking for beams or other supports that may be missing or that may need retrofitting as the building inspector goes through the house. But if you're looking at an older house, it may need to be retrofitted, and that might be a question you could ask a building inspector. This house is built before 1980. Do you think it would need an earthquake retrofit?
Okay.
Does that
Okay.
answer your question, Christy?
Yeah,
A
yeah.
little
I
bit?
was thinking, yeah, this thing about earthquake, I feel like in my house hunting journey, I've never really come up.
Mm-hmm.
Like I do check for if there's like foundation cracks, but I
Right.
don't think any inspector call out anything about this bell or crack might lead to we're more susceptible to earthquake, but no one really talks about earthquakes.
The foundation cracks themselves may not, uh, a retrofit will not necessarily solve those unless you replace a portion of the foundation. But
Mm-hmm.
whenever you're looking at a home, you really want to see what's the condition of the existing foundation. Are there issues with the existing foundation? Is it cracked? Is there what they call spalling, or when the foundation, the concrete is left holes or areas that are full of gaps, where the
Mm-hmm.
concrete is just not settled or is crumbled away? And then when the person's looking at how the foundation is connected to the house, older homes may have some anchorage and may have some good foundations or foundation sills, but some houses, especially the ones that were built quickly
Mm-hmm.
after the war, have sills that were that were brought in and put onto the wet concrete, and they're held in there by almost nothing. They're just nails and basic items. So it really varies. I personally am biased towards having an earthquake foundation because I've seen so many
Yeah.
pictures of damage. But some older houses have gone through several earthquakes and have done very well.
Hmm.
If you're looking to buy a house, I just recommend getting a clear idea on what the existing foundation is and how it's connected to the house.
Okay.
Yeah.
Yeah, I
Are you
so
looking in a specific neighborhood?
I've been looking at West Seattle a
Oh,
lot.
nice. Yeah.
Um, so what's the houses like there? Like it's definitely older.
Well,
Um,
we don't have a good, the URM maps that Amanda showed are just amazing, especially for brick homes. And there's some really good information there. Regrettably, the housing stock in Seattle is varies a lot, and we don't have a map showing the average age of homes. But they tend to be similar to their neighbors unless it's an infill. But it's now become so varied. Some of the houses are much older than their neighbors that it
yeah.
really depends. West Seattle has a lot of great houses and a lot of great older craftsman homes in that area. But as you're looking, you probably want to just, take, like I said, take a look at the foundation and stuff like that. Um, I can't really say for certain what would or would not need a retrofit.
Right. Okay. And the inspector would probably know that, right? I
They
mean,
can probably figure it out pretty quickly. And what you're looking at is the foundation connected to the framing? Or more importantly, how is the foundation connecting to the existing framing?
okay.
you can also so when I bought my house,
Yeah.
my inspector had said that like based off of his certification, he wasn't able to do that type of inspection.
Yeah.
And so I brought I went through a contractor that did a free consultation. And they came to my house and did an inspection, and they did tell me I do need to retrofit, and they gave me a quote and everything for it.
Yeah.
So we can't, at the city, we can't recommend specific contractors, but if you Googled like Seattle seismic retrofit, you would come up with a list of different companies that could come and provide that inspection for you.
Okay.
That's a really good
Mhm.
point, Amanda. There are contractors that specialize and do nothing but this, and I'm certain
Oh,
that there are building inspectors that do building inspections that are focused less on the structural and more on the other aspects of the house.
okay.
Okay?
Sounds good. Thank you so
Yeah.
much.
Thank you so much for participating and being part of this recorded item and asking questions. That is fantastic. Are there any other questions? I don't hear any. Amanda, do you want to check the chat one more time?
There are no questions.
Okay, great. Well, I'm hoping that this has been useful to everybody, and think that we will be posting this. And if you have questions, I'm going to just go ahead and leave this up for another moment here. There is my email, and Kristen, who is in the uh, subject matter experts for the earthquake home retrofits. If you have an unreinforced masonry building question, Amanda Hertzfield is fantastic. I did not know you were in FEMA before here. That's really cool. So anyway, please email us and bring us with questions, or visit the Applicant Services Center. Thank you.